Hello everyone, how you doing? Welcome to the next stream for IGCSE revision for Cambridge IGCSE. Okay, so I'm just going to dive in straight into what we were doing last time, and or rather the next question. And the next question in the paper, and the paper we were doing was 0478. It's 0478, but actually it's it doesn't matter which one it is. Whether it's 0478, 0984, doesn't matter. Anyway, we were doing the 2023 paper 2-1. So the paper 2, which is the paper, the programming paper. So it got on to this question here, because last time we'd done the logic gates question, and we were moving on to this question, which is the database question. There's always a database question without fail in the exam, so always make sure that you know this. It's a good way to pick up marks, and database work is, it's really good skill to have, basically. Okay, so a database table called TV range shows the main features and prices of a range of televisions. And there's our table there. It says, give the name of the field that is most suitable to be the primary key. And then we've got to state the reason for this choice. So if I just make it a little bit smaller, there's 2 marks, so 1 mark for each. So what we're going to go for is, it's going to be this first one here, TV code. And the reason for that is that every single row or every value is unique. So we can see if we look down it that there's no repetition, and that's what we're after. So if we look at the table like screen size, we've got 75 and 75, and that means for every row screen size is not unique. And the same for satellite, smart TV, we've got lots of yeses, lots of nos, so it's not unique. Even price is not going to be unique. So you're always looking for the field. So remember that a field is a column and a record is a row. So this time we're going to have TV code because every value in that is unique for every row. So let's just kind of recap actually the main things about databases. So remember, you've got a database table, which is looks a bit like a spreadsheet, but it's a little bit more than that, a bit more than a spreadsheet. But every column is called a field, so there's a little bit of terminology difference. Column is a field, and that is just like a data type. Each one has a data type, a bit like a variable in Python. And then every row is actually called a record, and I remember it because they both begin with R. And the data is related to each other. So if we think about that top row, we've got TV 90, SA, SMSD, screen size 90. It does have satellite, does have smart TV, does have a soundbar, and the price is 9,750. So all the data for that TV is collected together on that row. Okay, so let's look at the next question then. So it says, the database uses the data types text, character, Boolean, integer, real, and date time. Complete the table to show the most appropriate data type for each field. Each data type must be different. So really all we're looking at here and all we're thinking about is what variable type would we give this if we were creating a variable. So I'm just going to do a quick screenshot of this so I can put them side by side, because otherwise it's going to be really hard to see. So yeah, so there we are. There's the database data types, and we need to get a appropriate data type for each column. The first one, TV code. The second one, character. Third one, smart TV, and the last one, price in dollars. So for TV code, the first one, we're going to want to go with text because there is letters of the alphabet in it. It's got to be text. For screen size, well, we can see that those are integers. So do they have an integer? Yeah, there is integer there. So I would pick integer for that one. Smart TV. Now, although it says yes and no, and that technically is text, if it's yes and no, it's not actually yes and no. It's actually it's going to be a Boolean. So we're going to pick a Boolean for that one. And then price in dollars is going to be, that's going to be a real. So a real for that one there. Someone asks, what are we doing? We are doing exam paper from 2023. It's a paper 2 and we're looking at the database section of, we're up to the database question of this. So the next one, it says complete the structured query language SQL query to return the television, TV code, screen size and price of all smart TVs in the database table. So it's not going to let me write this. So what I'll do is I'll just open my Zoom up. Hopefully my Zoom's going to work. And yeah, that is my whiteboard on my Zoom. And I'll just write it out on this. So we've got select TV code. So what are we selecting? We're returning the TV code, which we've got already. So they've done that for you. The screen size. So the screen size is called, it is just called screen size, isn't it? Yeah, screen size. So it's TV code, comma, screen size. And the price. And the price is price dollars. So I'm just keep going backwards. There we go. So price dollars. And then the missing blank there is from TV range. And then where smart TV equals. And then it says all smart TVs in the database table. So where smart TV equals yes. Because smart TV is a Boolean. And there you go. Yes, smart TV, there is a Boolean yes or no. And we want it to be yes. And don't forget the semicolon on the end. Paper 2 is extremely difficult for you, so that's good that you're here then. So great, you'll learn lots from these sessions. Do look at the last 2 sessions because they've got the other part of the paper. If you weren't here, you can have a look at those. And you can speed me up and make me sound like a chipmunk. All right, so that is the answer to that one. So now that leads us on to the final question in this paper, and that is the 15-mark question. Now the 15-mark question, if you are one of my live students, you won't have covered this yet because we don't do it until the end of January. But what I'm going to do is I'm going to go through this and we'll look at the model answer. I'm not going to program it. I do have a video where I have done this, so I don't want to repeat it. What I will do is I will add to the comments afterwards a link to the video. In fact, I'll probably upload it if I haven't done it already. I'll upload a copy of me going through this, but we're going to look at the model answer. But let's look at the question first. So this question, the 15-mark question, you'll see right at the end, it's got 15 possible 15 marks. And really, if you haven't done a massive amount of programming, then I would suggest that you probably just leave this question and that you concentrate on other parts of the paper too. And the reason being for that is that this question is really for the more experienced programmers to shine and get sort of more marks because it's for them to shine basically. But I'm going to go through this. So we'll have a look at this. So we've got a 1D array, days, contains the names of the days of the week. A 2D array, readings, is used to store 24 temperature readings taken once an hour for each of the 7 days of the week. A 1D array, average temp, is used to store the average temperature of each day of the week. The position of any day's data is the same in all three arrays. For example, if Wednesday is index 4 of days, Wednesday's temperature readings are in index 4 in readings, and Wednesday's average temperature is in index 4 average temp. Temperature readings are in Celsius to 1 decimal place. Temperatures can only be from -20 to +50 inclusive, and that's degrees Celsius. Okay, so write a program that meets the following requirements. Input and validate the hourly temperatures for 1 week. Calculate and store the average temperature for each day of the week. Calculate the average temperature for the whole week. Convert all the average temperatures from Celsius to Fahrenheit by using the formula that we're given there. Output the average temperature in Celsius and in Fahrenheit for each day. Output the overall average temperature in Celsius and in Fahrenheit for the whole week. You must use pseudocode or program code. So what that means is either use Python or pseudocode, don't mix them. And use comments to explain how your code works. And actually we'll look in the mark scheme that if you don't add comments, you won't get as many marks. So it's really important to do that. You could come up with a perfect solution, but if you don't comment it, you won't get full marks. All inputs and outputs must contain suitable messages. All data output must be rounded to 1 decimal place. You will need to initialize and populate the array days at the start of the program. Okay, so there's quite a lot of stuff here. My main tips are, and I do have other videos on this, but my main tips are just use this bullet point here to tick off that you've done them. Take each one at a time, usually in the order that they ask you to do it, because that's usually the more logical way. But having said, if you do struggle with programming, you should be able to do always the first bullet point, at least, hopefully the first bullet point, which is normally to input and validate some kind of input. And that's quite easy. So you can get a few marks. Yeah, you can get a few marks for that. If you'll notice, though, that the sorts of things they're asking you to do, averaging, doing some kind of conversion, and then outputting things. So you're just kind of dealing with arrays, and they can only ask you now, especially 2026 onwards, to do averaging. So they change the spec. So you can only do like averaging, finding the minimum, finding the maximum, totaling and counting. So there's not a massive amount. You're not going to get asked some really random thing to do. There's a limited amount of things that you're going to have to do. Or they might ask you to do a bubble sort, but they have only ever asked that once so far since 2023. Right, so what I'm going to do is we're just going to have a look at the mark scheme. And yeah, it's this one here. And so they always give the mark scheme answer in pseudocode, and they do kind of go a little bit over the top. So if you do look at the mark schemes for these, don't kind of think, oh no, this is just ridiculous. I'm never going to write all this. They literally do write a whole load of stuff. You don't need to do it. They're not always the most efficient ways to do it either. Okay, so the first thing that we're going to do is we're going to input and validate the hourly temperatures for 1 week. And it does say that we have to input so we're going to input them here. The way that they've done is they've got the days array here. So we've got a days array, and we are setting everything to be days 1 Sunday, days 2 Monday, days 3 Tuesday, etc. So we know the days of the week are set. But then we're going to input the temperatures inside and validate them to make sure that they're within our range. So they've got week loop from 1 to 7. Total daily temperature is 0. And then from 1 to 24, because there's 24 days, then we're going to output. So remember, output suitable message, whichever day we're on, and then that's going to go into our in temp here. So we're just going to move down there. And then we're going to validate it. So the validation section here, it's just the thing here is not very good. So the validation section, I'm going to do a screenshot here because I can't write on it, and it's very annoying that I can't write on it. So I'm just going to do a screenshot and put it onto Zoom whiteboard. Sorry about this. So I'll just put it in here. And always having to faff around with my thing. There we go. Right, okay. So although I said you probably want to leave this if you're not very good at programming, what I would probably say is you should be able to do some validation, because all this is we're inputting here. We're inputting, and then we've got a standard while loop to check, have they entered, whatever they've entered here, is it within our range? So we've got this section here, which is just basically a range check. And they ask this over and over again. You'll see as we go through the papers, they ask this again and again. And if they don't enter something that is between -20 and 50, then we ask them to put it in again. If they do enter something, then it will just skip that while loop, and we enter that reading into our 2D array. Now our 2D array, and if we think about our 2D array, where's my question sheet? It did say there that we've got a 2D array called readings, and it's used to store 24 temperature readings taken once an hour. So if you think about how that looks like, readings will be, and actually you can see there it's the week loop. So it's like which week and which day. So effectively readings is like this. We've got readings, and we've got day 1, day 2, day 3, all the way down to day 7. And within each one of those, we've got 24 readings. So I don't know, -4, -2, 5, 2, 1, etc. And you've got 24 of them. So with the 15-mark question, like I said, it is really something for people who've been programming a lot, but that you should be able to, you might be able to get a few marks. So it's worth trying. Why did we add curly brackets in this code? Not in this one. I didn't see any. Yeah. Okay. Yeah, so if you're at this stage and you're not understanding a lot of this, I mean, stick at it, because you might start picking up stuff. I would say never give up, because, the exam isn't for another 5 months. So, yeah, just keep at it. Okay, so then we have got the... we've done the first bullet point, or they've done the first bullet point, input and validate hourly temperatures for 1 week. Calculate and store the average temperature for each day of the week. So basically, they're rounding as well. So what they've done too is they've added it in and then they've rounded it, which is fine, to 1 decimal place, which they asked for. And then the averaging, if you remember what we do for an average, you use the... they've got a total daily temperature here. They're adding it on. So they're already doing some of the summing. So remember, to get an average, you sum something and then you divide it by how many. And that's basically, we're doing the summing when we're adding in the temperatures. I might just appear for computer science in October. Yeah, I mean, I see how you feel, because sometimes if you need to, a little bit of extra time can help. Yeah. Okay, so they've summed that and then they worked out the average here, which is the next bullet point, and then calculate the average temperature for the whole week. And they're doing that in this one here. So we've got a for loop for 1 to 7. We need to get the total and then add that on to the average. And then we've run out of code. Let's get the next bit of code. Which was here. Yeah, so that's all they're doing, and that's that bit of code there. And then they've got the it does not like me trying to select the text. I'll do another screenshot. Then we're converting it from Celsius to Fahrenheit. So if we have a look at that code, we are converting from Celsius to Fahrenheit. Now, I would suggested doing a function for this, but they haven't done that. They've just done a for loop. That's up to them. But yeah, all we're doing is for each one, we are converting it here. And rounding it as well. And then we're just outputting it here. And then output the average temperature, so which we've done, and then output the overall average temperature for the whole week. And that's that last bit of code there. So I think the main thing with these is, if we have a look at the mark scheme, the way that they mark it is if you can even just get some kind of input and output, at least one programming technique has been used, and you've tried to store some data, then you can get between 1 and 3 marks. So even if it's not 100% right, it's not all or nothing. And even if you kind of like do that first bit, which is getting the input and checking the validation, you could get sort of 3 marks from that section just for that. However, to get the full marks, up to 9 marks for the first section of the 15, you must have a range of programming techniques and you've done all the criteria. So obviously, to get the top marks, you need to have done everything. And even if you do sort of a few bits of syntax errors, that's absolutely fine. They don't mind a few syntax errors. The second part of the marking is, have you commented it? So if you haven't put any comments, you won't get any marks for that. Use appropriate identifier names. So make sure that you have variable names that are really good, that mean something, and try and keep your solution logical. So you can see there, it talks about the solution is illogical. The solution is inaccurate, but you can still get some marks, even just for doing some of it. And I've marked mock exams many times where I've had students just do a few lines of code, but what they've written might be that input with the validation check. And, I could award them 3 or 4 marks, which isn't, okay, it's not 15, but it all adds up. So we've got, for the maximum amount of marks though, 5 to 6, we've commented everything, suitable identifiers with names, make sure you use good variable names. The solution is accurate, the solution meets all the requirements. So, I would say, even if you are struggling with this, obviously, if you're one of my live students, we haven't done this yet. But even if you haven't done anything like this, keep at it, and I will point you in the right direction of the coding videos for this, because it's just practice, practice, practice. Do you have any basic videos uploaded on your channel for Python, you mean? Excuse me. You're going to revise hard and do the exam, and then you don't have to revise over the summer. That's fine. Yeah. Do I have any basic videos? Not a massive amount, no. There might be a few earlier on. I haven't done any recently. So that's that paper finished. We're just going to move straight on to another exam paper, but we'll move on to a paper 1, and we're going to do the March paper 1. And the March papers are kind of interesting because, well, I say they're interesting. The March papers are specifically for India. And the Cambridge Exam Board have a lot of students take their exams in India, so much so that they have their own sitting. So normally, you know, here in the UK we have May or we have November, but yeah, I think they must make a lot of money. So yeah. What did you miss? You missed me going through paper 2 and the 15-mark question. So yeah, so we're going to do the February-March 2023 paper. And the only thing I'd say about the February-March papers is you might find some of the questions, the English is a little bit plainer because most of the people taking this exam, English is not their first language. But that's not to say that they're easy exams, because they're not. In fact, I quite often find that some of the questions they ask in them are harder than other ones. But anyway. All right, so let's just start. So our first question, see if you can get any of these. Computers can be infected with malware. Spyware is one example of malware. Tick one box to show a correct definition of spyware. Is it software that activates a webcam and transmits a video to a third party that outputs it live to a website? Software that detects when a password is being entered and then emails the password to a third party? Software that records all data entered into a computer, analyses this data to find email addresses and passwords, then posts these to a website. Software that records all key presses and transmits these to a third party. Is computer science getting leaked again this year? I hope not. I hope not. So which one do you think it is? So C is a good guess, but it is actually D. Software that records all key presses and transmits these to a third party. So it just sends literally everything it can, which, you know, yeah, because there might be other stuff that it might want. I mean, if you think about why is there spyware? Well, obviously, some people are after username passwords, but not everybody. People might be other people might be after other things. So yeah, it's yeah. That's okay. That's okay. Yeah, that's why you're here. You're revising with me, so that's a really good step forward. So that's fine. All right, let's look at the next question. Now, this there's a lot of writing in this one. Unusually, complete the table by identifying and describing 2 other examples of malware. So can you think of a couple of other malware examples and a description of them? And obviously, if you don't want to type them, just kind of think of them in your head. And then we'll look at the mark scheme in a moment. Yeah, good. Trojan horse is one. Yeah, good. Yeah. Let's have a look at the answers. So there's quite a few that are on the syllabus. Yeah, adware's a good one. Yeah, yeah. That's another one. So we've got a virus. So a virus is a type of malware. It's software or code that replicates itself when the user runs it with an active host. It deletes or damages or corrupts data files or takes up storage and memory space. A worm is software or code that replicates itself on a network without user input and without an active host. It takes up bandwidth, deletes, damages, corrupts files, takes up storage, memory space. They all pretty much do that. Opens back doors to computers over the network and is used to deposit other malware on network computers. Then there's Trojan horse, which is software code that's hidden within other software that's disguised as authentic software. There's a lot of antivirus software that is disguised as that is actually viruses. So they're not actually antivirus, they're viruses themselves. And yeah, so when it's downloaded, the other malware it contains is installed. So you install the software, but you install the virus at the same time. Adware, which generates and displays adverts on a user's computer, may contain spyware or other malware. Some, when clicked, may link to viruses, reduces device performance, reduces internet speed, and redirects internet searches to fake websites. And then ransomware is software or code that stops a user accessing using their computer by encrypting the data files of the computer, and a fee has to be paid to decrypt it, and it has to be paid to release the computer or device or data. And yeah, ransomware is a big problem lately. Okay. One other thing here in the mark scheme, it does say e.g. And I would say for that, if you've got an example that isn't in this list, that's absolutely fine. You would still get marks. And remember, with things like cybersecurity, these are, changing all the time. There's new types of viruses, etc., coming out all the time. All right, next question then. Proxy servers and firewalls have some similar functions. Identify 2 similarities and 1 difference between proxy servers and firewalls. Can anyone answer any of those? They both block traffic coming from the servers. Yeah, that's a good answer. Yeah. Yeah, that's a good one. So what I might do is I might just go through proxy servers and firewalls. It is really easy to get them mixed up. So they both can change the IP address. Yes, yeah, they can actually do that. Oh, no, they can't. No, they can't actually. So firewalls don't do that. They just check. So let's have a look at what they do. So a firewall will sit in between. So there's your firewall. I'll just mark it as F. There's your computer or network, because you can have firewalls on a network and you can have a firewall on a computer, and then you've got the internet there. And basically what firewalls do is they're a bit like a bouncer on a nightclub. They will stop data coming in that's not approved. So there's a list that they approve to come in or out, and they will check to see, is this message coming in on the approved list? And if it isn't, then it says, sorry, you can't send that message. If it is on the approved list, it will send it through to the computer or network. Now, with proxy servers, what they do, and yeah, so this list is user defined. So the user defines it. A proxy server, well, it does a couple of things. In the context of cybersecurity, it sits between your computer or your network and I'll put PS for proxy server. And yeah, it's kind of like a buffer to stop the rest of the world or the internet accessing your computer network. So it's kind of like almost they're not connected. They have to go to the proxy server. They can't get direct access to you. So another thing that proxy servers will do is they will change your IP address. So there's lots of ones out there that you can pay for. Some are free, but I would be careful of if you do use them. But they will hide your IP address because, you know, you might want to watch something on US TV, but it won't let you because you're in the UK. A lot of people use proxy servers to change their IP address when they want to watch things on the BBC here in the UK, because if you want to watch sort of like iPlayer or whatever for the BBC, you have to be in the UK. And yeah, so you can sort of change it to a UK one. That's not really in the context of cybersecurity though. The whole point of a proxy server is it just sits as a buffer between you and the internet. And normally what it holds is web pages. So if you've got a web page, it's effectively a web server or a copy of your web server, but it's not the web server itself. It just holds it so that no one can hack you, basically. And so if they can't access your network via the internet, they can't hack you. So the similarities, they check incoming and outgoing signals or filter traffic. They have a whitelist or a blacklist of what is allowed. They block incoming or outgoing signals. They both block unauthorized access. They keep a log of the traffic. And they both can be hardware or software or both. Differences, like I said, proxy servers can change your IP address, but firewalls can't. The proxy's intention is to divert attacks from a server. The firewall is to stop unauthorized access. So the proxy sits there as a buffer, basically. Proxy protects a server. Firewalls protect individual computers. Well, I don't agree with that because firewalls can and are on networks as well. So I don't agree with that one. I would say that's a similarity. Proxies examine, processes requests for a website, but a firewall does not. Proxy processes client-side requests, whereas a firewall filters packets. That is true. Proxies transmit website data to the user, but a firewall does not. Proxies allow fast access to a web page using cache, but a firewall does not. So yeah, the whole thing is that a proxy is not only really safe for stopping hackers, but it's supposed to speed up your internet, your web server. Yeah, absolutely. A firewall's there to protect your data. Absolutely. Proxies transmit website data to the user, but a firewall does not. Proxies allow fast access to the web page. That's where I got up to. And then proxies can hide internal network from the internet. That's the whole point of them. But a firewall cannot. That is true. Yeah. So lots of things for those 3 marks. They don't normally ask you this amount of detail, though, on
proxy servers and firewalls. That's quite unusual. Yeah, we'll just carry on for a little bit longer. A programmer has designed a 3D interactive computer game. They are going to develop a program for the game. The program needs to run efficiently, but it must also be developed as soon as possible. Tick one box to identify whether the programmer should use a high-level language or a low-level language to develop the program. Explain the reasons for your choice. So 1 mark, well, no, actually it's 4 marks for explaining. You don't get a mark for picking one. Which one do you think you would use? And really all this question is getting at is why would you use that particular one? And what is the differences between high and low level? That's really what they're getting at here. Yeah, we definitely want to use a high level language for this. Absolutely, yeah. Now the reasons for it is that, and let's have a think about why we want to use high level language. Well, actually what you can do is you can say the negative of low level. So there's a number of ways that you can answer this. So you could say low level is mainly for programming devices inside a computer. So that's not what you're doing. You're doing a game. So therefore, it's not suitable for a game. High level requires a human interface. You can do an interface for low level, but it's very hard and time consuming. And that leads me to the next point, which is low level is very slow to write programs with interface, and you can say with interfaces if you want to, but they are just very slow anyway. Yeah, and low level is very, well, it's not quite binary, but it's very similar to binary. So it's, yeah, it's just slower. High level languages are portable. So that's one of the reasons why we want to use it. So that means you can use it on, you know, Apple or or Microsoft or Android, etc. So you can use a high level language and put it on lots of different devices. And you can't do that with low level. So that's one of the big, sort of really big problems that you have with it. High level are also easier to debug. And with a game, you don't really need to what I'm trying to say, you don't need to manipulate hardware. You don't normally need to manipulate hardware. I mean, it could be that, or devices. That's what I mean. So, you know, if you've got a graphics card, you're not normally going to be doing anything directly with the graphics card. The graphics card is just going to display your game, if you see what I mean. Let's have a look at the... because I haven't got all of this. There must be other things that I've forgotten to mention. So yeah, high level is, so actually I said high level, but they've said no mark for the choice. So you could actually have picked low level. I mean, that's just crazy. But anyway, high level, it's easier to program, read, write, understand, and therefore the program is less likely to make mistakes in a shorter, and they can write it in a shorter time frame. It's easier to debug, find errors, correct them, so the programmer can find and correct errors in less time. The game will be machine independent or portable, can be used on any computer without the need for understanding the hardware of that computer, and the programmer can focus on the problem instead of the manipulation of the memory or the hardware. And if you pick low level, it is more memory or RAM efficient, 3D graphics will have high memory consumption, allows direct manipulation of memory, allows for more efficient control response time, allows for specialised hardware. But no one's going to write a game in low level unless they're absolutely crazy. Okay, I can't believe how fast this 45 minutes has flown by. So we'll pause there and we'll finish. We won't finish this tomorrow, but we'll carry on tomorrow with the next section. So if you did want to have a look at this exam paper, it is March 2023, paper 1-2. It's just there's only one for each one, and for March, and yeah, and we'll carry on. We'll carry on tomorrow. Yeah, so low level was an acceptable choice. That's crazy, yeah. All right, take care and see you tomorrow, hopefully. Bye.